In this video, I want to show you how you can calculate percent change between two sets of reactions. So what I have here is some old data from another semester, and the homogenates are the pink and the red and the orange homogenates. And let's say, and obviously this is like yours because we have the reaction and reaction plus 1 millimolar, 2 millimolar, and 4 millimolar. And so let's say we want to look and see whether 2 millimolar malonate had any significant, if the effect of 2 millimolar malonate on the pink homogenate was significantly different from the effect of 2 millimolar malonate on the orange homogenate. And while I have the average down here at the bottom, we can't just compare the average. What we have to look at is percent change. And so to do that, you're going to have to move some columns of numbers around. So let's take, let's going to copy this set of numbers, copy, and we're going to put them over here. And we're going to call this 0 because it's 0 millimolar malonate. And then we're going to copy this set of numbers over here. Control C, and there we go. And this is with 2 millimolar malonate. Now, you'll notice that some of these, in this case, there's one set of numbers that doesn't have a pair because I had deleted some numbers because they were sort of way out of range. So I'm just going to highlight both of these, and I'm going to delete both of them, right? And you can't just, you have to delete both pairs of numbers because you need to keep the pairs of numbers together. Right. Now for this column, we want to look at the percent change. And so the calculation, as described in your lab manual, equals, I'm going to parentheses, it's this number minus this number, the difference between them, and close parentheses, divided by this number. Okay. And so it's a 43% decrease. The negative 0.43 just means it goes down 43%. It's a 43% change. And we want to do the same calculation for all of these, but we don't want to have to type in all those calculations the same. So I'm going to click here and drag down, and then go to the fill function, down, and that automatically does the same calculation. And then if I average all these numbers here, I can average them, and I can see that the average decrease in response to 2 millimolar malonate is 36%. Right. So that takes care of the effect of 2 millimolar malonate on the pink homogenate. I want to do the same, and I'll just call this pink up here so I don't lose track of what's what. And that's the pink. And I want to do this again for the orange homogenate. So we'll do these over here, and we'll choose orange. Right. And the same thing, I'm going to choose this set of numbers. And I'm going to stick with 2 millimolar again because I have to compare the same concentration. Right. And again, now I'm going to have a number of things I'm going to have to delete because there's nothing to compare here, so I'm going to delete that. And I have to delete all of these. All right. So I don't have quite as big a sample size in this case. And again, I'm going to do my percent change. So equals, parentheses, we did this number minus this number. It really doesn't matter what order you do it, as long as you divide by the first number, close parentheses, divided by this number. If you do the lower number first, the second number, what you're going to see is the percent decrease. I would have got the same 50% decrease if I'd done 0.059 minus 0.56, I'm sorry, not 50% decrease, 5% decrease. I would have had the same 5% decrease if I'd done it the other way, but it just wouldn't have a negative in front of it. So same difference. I'm going to go like this, and I'm going to fill down. How come all my numbers went positive? That's weird. What happened here? Oh, obviously I did something wrong. So something did wrong, so it looked, let's do this again. Let's do this again. See, if you have a thing, it doesn't look right, you do it again too. Minus, parentheses, this number minus this number. Right? And I just cut the wrong one. Fill down. There we go. That looks right. And I also want to average this number. Sorry, wrong thing here. I'm going to do the average. And so we see for the orange homogenate, 2 millimolar malonate causes a 31% decrease in activity. So then the question is the 36% decrease in activity seen in the pink homogenate significantly different from the 31% decrease seen in the orange homogenate when 2 millimolar malonate is added? So to do that, now you need to do a t-test. Now you can do a t-test with Vassar stats, and the columns of numbers you're going to copy is this column right here and this column right here. Right? These are the two columns of numbers you'll copy and paste and put into Vassar stats. Or alternatively, of course, you can just do a t-test in Excel as well, and I'll just review how to do that. So we're going to say we're going to equal a t-test. And array 1 is this set of column of numbers here, and you hit a column, and array number 2 is this column of numbers here. We'll include that 0, comma, and this is going to be a two-tailed test, type 2, and the p-value that I get is 0.59, obviously a lot bigger than 0.05, so we can conclude that 2 millimolar malonate acts exactly the same way on SDH from the pink homogenate as it does from SDH in the orange homogenate.